Hey class, welcome to part 2 of the video tutorial for this worksheet, the organic nomenclature worksheet. So I'm going to go on to the next part here. There'll probably be a part 3 for some stuff on the bottom. Whoops, sorry about that, that's my phone. Let's just go. Okay, so if you listen to my directions here for this part, you can answer this one. Okay, so you'll see how if I can remember to kind of bring it up again. But essentially, it's pretty simple. The first thing you need to know is how many carbons do you have here? Okay, so you have 1, 2, 3. I'm highlighting each carbon you see. 4, 5, 6. So I have 6 carbons. Okay, so let's switch over to my other tab really quick. Okay, so right now, if you guys remember from your notes, okay, in case you didn't watch the first part, here are the prefixes for just how many carbons you have for anything. Okay, so in this case, you have 1 carbon here. Its prefix is methane. Okay, this next one here, you have 2 carbons. You have, let's see, ETH, that's ethane. Okay, if you have 3 carbons here, you have propane, that's the prefix I'm looking for, pro. Okay, so forth. I have 4 carbons, that's butane. Okay, bute. If you have 5 carbons, the prefix I want you to see is pent for 5, pentane. Okay, let's go to the next slide. If you guys can see this, I have 6 carbons on that. The one on let's see, on here. I have 6 carbons on this one. So let's look at the prefix for 6 carbons. It's right here. It's even in parentheses how many carbons are. So the key prefix I want to look at is hex, okay? Because there's 6 carbons attached to each other, right? All right. Okay. So over here, what I'm going to do is I'm going to put, I'm going to leave some room here on the left. I'm going to put hex. Now, the reason why I didn't say hexane is I want you guys to look. Whoops, I did. I was supposed to not do that. Hex, just hex, okay? I just want you to write hex. That's H-E-X, hex, okay? It's an H, and it looks like an N, but it's an H, okay? The reason why I didn't put hexane is because you guys got to look at the bonds. If there's any double bond, it changes your name immediately. Are there any double bonds? Right here, I'm circling it. I know it kind of sucks to see that. I circled that double bond. I'm going to have to erase that. I know that kind of sucks. But again, that double bond right there that I'm circling, okay, what it's going to do to the name is it's not going to be hexane anymore. Because there's a double bond, I'm going to call it hexene. That last part, hexene. Here's a clue. Name or draw the following hex or alkene. Okay, these are any mix of carbon and hydrogens together with some kind of double bond somewhere, right? So that's a double bond right there present in this one. So here's the next step that's kind of hard. I got to count the carbons that I have, meaning like I got to count them in order. 1, 2, 3, 4, 5, 6, right? I can count them this way in this order. Or some of you guys might be asking, what if I count it backwards? Which is perfectly fine, because if you guys remember, this in a container, it could be switched completely backwards, all right? Okay, imagine this in 3D, okay, floating in water, okay? You guys can count it however you want. 1, 2, 3, 4, 5, 6. You guys can count in whatever order you want, but only one order will work for naming it correctly. What I mean is this. Which carbon does the double bond start at? Okay, if I go from left to right here, 1, 2, 3, 4, 5, 6, it would start at the second carbon, right? If I count it from here, from this carbon here, like on the top numbers, if I counted this 1, this is the second carbon, third carbon, fourth carbon. If I counted it in, it starts at the 4th carbon. Now, the thing that chemists do to kind of not mix up the order or mix up the names so we don't have like 2-hexene here or 4-hexane, I only choose 1. And what it is the rule is I always choose the lower number. So guess what? What's lower, this 4 or this 2? Okay, so if you know your math, it's going to be 2. So instead of calling it 4-hexane, the final name that I'm going to go with that chemists are going to recognize is 2-hexene. Okay? Again, the reason why we have this lower number structure, so we don't have 2-hexene, 4-hexene, meaning the same thing. That will confuse a lot of chemists who, need to know what it is exactly. They just want one nice formula. So they always go with the lower number, okay? So that's 2-hexene. Let's go the other way really quick. if we have a 2-pentene. Now again, pent. Now I'm not going to go back to that slide, right? Because it's a pain. But that means pent means there's 5 carbons. Okay, so let's just draw that really quick. 1, 2. I'm going to kind of stagger them. 3, 4, 5, just so I can have a little bit more room. Okay, there's 5 carbons connected to each other, right? And I'm just going to number them right now. 1, 2. Now, when you're constructing it, it actually doesn't matter what order you go on. When you're constructing, I know it's confusing. I could have numbered this one 1, 2, 3, 4, 5. Okay, because it's already named at 2-pentene, it really doesn't matter because the point is the double bond's going to occur at the lowest number already. It's already been named, so you don't need to worry about how you necessarily number it. Okay, so hopefully that didn't confuse you. So just follow me here. I decided to number these from left to right. I'm going to stick with that, and that's that. Okay. So let's just stick with that. I number these carbons from left to right. 1, 2, 3, 4, 5. Okay. Here's the thing. That 2 dash tells me exactly where the double bond's going to be found. So I go to the second carbon right here. And I'm going to draw not just a single bond between these 2 carbons, but I'm going to add one more bond here. Now it's a double bond. Okay. I need to draw this in order to properly like kind of write the condensed version right here, like write the correct chemical formula. Okay, so I need to draw this really long drawn one, right? So again, how many carbons or how many bonds can this carbon have? Every carbon can have up to 4 bonds. Okay, so that means I have this one single bond from this carbon out here to this carbon. So that's 1 bond. How many more bonds can this carbon have? 3 more, because it can have a total of 4 bonds. Okay, and remember, each of these extra bonds that will connect with something else, it's going to be typically hydrogen. Okay, it's 1 hydrogen. It's another hydrogen. It's another hydrogen. Okay. The tricky part is this one here. This carbon in the middle. Let's see how many bonds, extra bonds I'm going to have to draw. It can have up to 4 bonds, and it will have 4 bonds, right? There's a bond right there. That's 1. But look at this one. There's 2 bonds now. Now there's 3 bonds. So how many more bonds can this carbon have? It can only have 1 more. Remember, it can only have 4 bonds. So meaning this bond, 1, this bond, 2, and then this double bond, 3 and 4. Okay. So now this carbon has a total of 4 bonds, and guess what it's going to be bonded to? By default, it's always going to be hydrogen. So that guy only has 1 hydrogen. That's it. We got to stop right there. It can only have 4 bonds. This one is the same case. 1, 2, 3. So this carbon can have 1 more bond. Okay. This one's a little bit trickier. See, this carbon has 1 bond, 2 bonds. How many more bonds can it have? It needs a total of 4, so it's going to have 2 more bonds. And they're both going to be hydrogens. See if I can draw that. It's a pain. And the last carbon right here has only 1 bond attached to it, so that means it has 3 bonds. And I'm going to just draw on the hydrogens for you guys really quick if I can. Shoei's getting a little bit tired. He's had a great weekend. How was your weekend, everybody? Good? Okay, so here's what I'm going to do. I got all this. It looks like a mess, but just focus one by one for each carbon. That first carbon, carbon number 1. I got C. Right, how many H's there are attached to it? Just to this carbon. 1, 2, and 3. CH. 3, right? Then here's the next one, the second carbon right here. I'm just going to write C, the C, and how many H's it's attached to. 1 H. That's it. It's only attached to that 1 H. So here's what it's going to look like. Isn't that beautiful? Okay, now what do you notice? There's the double bond. So just kind of like this one right over here, number 5, I'm going to, where my double bond is on which carbon, I'm going to draw the double bond. Because I could presume that these 2 carbons are just singly bonded if I'm not going to draw in like this little double bond here. Okay. If there's a double bond, typically chemists will actually show you where it is when they draw the molecule. Otherwise, you can presume that each of these carbons is just singly bonded to each other, right? Okay, so let's see. Okay, so my video is almost up. So the next one's going to be CH because it only has 1 H, or it only has 1 hydrogen connected to it. Sorry, I just see my limit counter coming up. Okay, let's see. This next one has two H's here. If you guys look closely, all right. Again, this carbon here has 2 H's, and then so I'm going to put the subscript 2 right there, and the final carbon is going to have 3 bonds or 3 H's. Okay. All right, guys. That's all I have for you guys. Peace.